Observe these pictures. You see that each picture looks exactly the same as the other, or in geometry we use the term congruent in the sense that it has the same shape and size. So if two figures have same shape and size, I can say that they are congruent. Now to denote this congruent, I have a symbol. So this is the symbol which represents or shows congruent. The two lines at the bottom show same size, whereas this inverted S here shows same shape. So same shape and size, I get congruent. Now to prove congruency, what we can see is if things perfectly overlap, then they are congruent. So if objects or things perfectly overlap, then they will be congruent. Different rotations of a same thing, different rotations of one same thing are also congruent, and mirror reflections are also congruent. So perfectly overlap, different rotations or orientations, and mirror reflections are also congruent. We have these two line segments here, AB and PQ, of the same length, 20. Since the length is the same, I can say that AB is congruent to PQ. Note that the position of these two lines does not matter because different positions give me congruent things. Similarly, two angles can be said congruent as long as the measure of the angles is the same. So here the angle measures 36 degrees and here also the angle measures 36 degrees. So we can say that angle BAC is congruent to angle EDF. So both these angles are congruent. So we've seen when lines are congruent. We've also seen when angles would be congruent. Now let's see when would triangles be congruent. So with these lines and angles, I get a triangle. A triangle has nothing but lines and angles. So 3 lines or 3 sides and 3 angles. So when sides are congruent, or I can say the lines are congruent, these lines are sides in case of a triangle, and when angles are congruent, I can say triangles will be congruent. So these two triangles I can say are congruent when all the 3 sides are congruent or all the 3 sides are equal. So here you have AB which is equal to QR, BC which is equal to PR, and AC which is equal to QP. So all these 3 sides are equal. Again, 3 angles are also equal. A is equal to Q, B is equal to R, and C is equal to P. So I have 3 pairs of equal angles. With these 3 sides and three sides, corresponding sides being equal and corresponding angles being equal, I can say that the triangles are congruent. So I can say that triangle CAB is congruent to triangle PQR. Now the way in which you write that the triangles are congruent is slightly tricky. So listen to this carefully. The order of the first triangle does not matter. So whether you write triangle CAB or BCA or ABC, it does not matter. But once you fix this, the second triangle automatically gets fixed. How? You have triangle CAB and you write congruent to. Now the second triangle would be C corresponds to P, so P. A corresponds to Q, so I have Q here. And B corresponds to R, so R. So without looking at the figure, I know that triangle CAB would be congruent to triangle PQR because I know the vertices correspond. A corresponds to Q, B corresponds to R, and C corresponds to P. Similarly, you can write that triangle ABC would be congruent to triangle QRP. So the vertices should correspond. So that's how I get that with sides and angles, triangles would be congruent. And not just this, the converse also holds true. So if I am given that these two triangles are congruent, what can I say? That the sides, corresponding sides and the corresponding angles would also be congruent. So I know that these two triangles are congruent, corresponding sides are congruent, corresponding angles are congruent. But now, rather than saying corresponding sides are congruent, corresponding angles are congruent, these sides and angles are nothing but parts of the triangle. So I can say that corresponding parts of the triangle are congruent. And again, this 2 is a pretty long sentence. So rather than this, I can use a shorthand notation which is CPCT, which indicates corresponding parts of congruent triangles. So CPCT is a short form by which you can say that if two triangles are congruent, then the corresponding parts would also be congruent. So we've seen that to prove that two triangles are congruent, I need to show that all the sides are congruent and all the angles are also the same. So now it would be a very tedious process to check all the sides, if all the three sides are equal, and then measure all the angles and find whether the angles are equal. So rather than that, we have a few easy methods which are sufficient to prove congruency. So let us see which are the methods. If three sides of one triangle are equal to three sides of another triangle, it is sufficient to prove congruency. If three angles of one are equal to three angles of the other, it is not necessary that the triangles are congruent. So it is not sufficient to say that the triangles would be congruent. When you have two sides and one angle, it is important that the angle is included within the sides. So the angle should be within the sides. Only then can you prove congruency. By other method, you cannot prove congruency. So when two sides and one angle, the angle has to be included within the sides. When you have two angles, one side equal to two angles and one side of the other triangle, then it does not matter whether the side is inside the triangles, inside those two angles, or it is outside these two angles. So both of these are sufficient to prove congruency. In right triangles, we have a special case. It's a special case of SSS only, which is RHS. This holds only in right triangles. So this is also sufficient to prove congruency in right triangles when you have a hypotenuse and one side of one right triangle equal to the hypotenuse and one side of the other right triangle. Now, let us try to look at each of these sufficient cases. So what do you see here? 5, 4, 6. Three sides are given of this triangle. And here also the three sides are 4, 5 and 6. So three sides of this triangle are equal to three sides of this triangle. So I can say that the triangles are congruent by side, 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 which is SSS. So I can say triangle ABC is congruent to triangle DEF by SSS. Now let's look at these two triangles. I have two sides and one angle. Two sides, one angle. When two sides and one angle are given, it is necessary that the angle should be enclosed within these sides. The angle is enclosed. So now 5, 6, 5, 6 and 40 each. So I have two sides, one angle of this triangle which is equal to two sides, one angle of the other triangle. And hence I can say that these two triangles are congruent by side, angle, side. The angle is enclosed between these two sides. It's included between these two sides. What about these two triangles now? Two angles, one side. Two angles, one side. So two angles and one side are equal to the two angles and one side of the other triangle. So I can say that the triangles are congruent by angle, side, angle. Now when two angles and a side is given, it does not matter whether the side is included or you can have any other side also which is equal. So angle, angle, side or angle, side, angle. You can say that these two triangles are congruent by either of these two methods. Now in right triangles, there is this special case. In right triangles, if the hypotenuse is the same, hypotenuse here is PR, hypotenuse here is DF, the hypotenuse is same and apart from the hypotenuse, there is one more side that is same. I have RQ which is equal to EF. Then I can say that the triangles are congruent by right angle. I have a right angle, holds true only in right triangles. Hypotenuse, the hypotenuse is same and one more side. So I can say that this triangle is congruent to the other triangle by RHS, which is right angle, hypotenuse, side. So these were the different ways in which it is sufficient to show that the triangles would be congruent.